And this week we are going to be getting into um, data visualization using ggplot2, which is the base package for data viz in R. Hold on, there we go. And to be quite honest, as I was saying to Vanessa before we got started today, I think data visualization is the one thing that R is pretty much superior to any other programming language out there. So, as far as like running in ANOVA, doing data filtering, like, there are other, languages and programs like SAS or Python that do just as good a job, if not better. But, really the main advantage of using R is the data visualizations and the quality and the breadth of what you can do in that programming language. So this week, we're going to go back through the clean beaches data set. There should be a clean beaches underscore new.csv file under the week 3 folder on the OSF page. So if you haven't downloaded that yet, you can download it there and put it in your data folder. In addition to using ggplot2, which is part of tidyverse, we're also going to be using the ggb swarm package, which just essentially allows us, if you have many dots on a scatter plot, it can add a nice little dodge, so that way all of the dots don't overlap each other, which can become a problem if you have a lot of data points, say in the hundreds or thousands or hundreds of thousands of data points. So yeah, let me get into the basics of how to use ggplot. So I'm just going to run those. And remember, as I run tidyverse, it's importing 8 packages here. And one of the first ones is this ggplot2 version 3.3.3. One thing to note about ggplot is every time you download an update, if you have saved a plot, so like let's say you save the R data file and you have a plot in your environment already loaded, if you try to replot that same saved object with a new ggplot version, it won't let you do that. So you have to rerun the code. And that's another reason why I say you should have your all your programming scripted out, so that way it can run on its own and you don't have to go back through and click individual portions to get the right plot, if that makes any sense. All right, so the basics of ggplot. We can kind of incorporate it with the same tidyverse functions we have, like the pipe. So we have imported the data set already, and this time I'm calling it plot beaches. And so what we can do is say plot beaches pipe to ggplot, right? And so ggplot is the base function. And at this level, what you're doing is supplying the data argument, which is essentially saying pull this data frame. And then you have this neat little portion called AES, which essentially stands for aesthetics. And you can assign different values to different aesthetics. In this case, all I have is X and Y, and that essentially means X-axis, Y-axis. And so on the X-axis, I have year, and on the Y-axis, I have beach bugs, right? So what it's going to do is separate all the beach bugs data by year and on the X-axis, and then just plot it vertically based on the number of beach bugs that were measured. And then I add a little plus sign to the end of that, so that I've supplied it the data, the arguments for the axes, and then the plus sign to geom point. And that's essentially saying, take that data I've given you and create a data point on the plot for each point I've provided you. And then one thing you'll notice here is that I'm assigning it to P1. So that's just kind of my regular nomenclature. That's my first plot that I'm plotting, although sometimes I will give it more descriptive names. And then you'll notice these 2 parentheses at the beginning of end of this code. And what this allows me to do is it allows me to save P1 while also simultaneously plotting P1. So if I run this, highlight it, or I can just put my cursor at the end and hit Control Enter or Command Enter if I'm on a Mac. It will save P1 and produce the plot for me. Okay. And one of the things it tells me is warning message, remove 29 rows of missing values, right? So if the data set has any missing values, in this case, it's probably for beach bugs, it's just going to remove them from the plot. It's not going to just create a random value in its place. So what we have here, we can hit the zoom button to expand it out. We have all the individual data points. And as I mentioned earlier, we have a problem here because we can see some of them, but in some cases we have just like a bar here. And what that's telling us is there's so many data points at those values that they're overlapping. And then another thing here is, and we'll get into this kind of later in the instruction here, is we have these outlying points. So, there's a lot of compression around 0, and we really can't see any differences between these data points unless we get up into the thousands or really hundreds of values of difference between beach bugs. Make sure I have a chat open here so I can make sure I'm answering questions as they come up. There we go. Oh. There we go. So that's the basic, very basic, just XY scatter plot. Now, what we can do is even create summaries. So last week we learned how to use the summarize function. So what we can do is create a data set called sum1. So we can supply the data, pipe it to group by here, pipe it to summarize, and then give us the number of observations. And again, this little parentheses feature works for pretty much anything. The parentheses just mean run within, but output it to the console once it's done. Right, so we can see the number of observations per year. And this will become important if we ever want to plot summary statistics, right? So if we wanted to just get the means and standard deviations, we could do that, and then we could just plot a dot with some whiskers, which we'll get into a little bit later. One of the other things we can do if we have overlapping points is we can add a jitter. The thing about the base geom jitter is it's going to add a dodge, or it's going to move points both on the X and Y axis. And that's essentially just to avoid overlapping points and jittering them. So we can run that. So it's the exact same thing, except instead of saying geom point, we just say geom jitter. We run that, and you'll see here, I don't want to update right now. We have the points kind of spread out, but even down here at the bottom where we're close to 0, there's still so many overlapping points that even when we jitter, yes, correct. P1 is saving to the environment, not to a file. Now I'll get to where we can save it as a file. Well, really save it as an image file a little bit later. But as you can see here, even the geom jitter here is not entirely helpful because there's so many data points down here around 0, or really between 0 and 500 here, that even with the jitter, they're still going to be overlapping. Another thing we can do is add colors to the plot, right? And this is, as Vanessa was saying before we got started, the color palettes in R are pretty vast and easy to use. And in fact, a lot of the basic ones are colorblind friendly, which is very nice. It makes it very easy because you have these palettes that you can just choose from, and it's going to be colorblind friendly. Okay, so in this case, we have plot 3. So we're going to add a jitter with colors this time. So again, plot beaches. In this case, I'm going to remove the missing data. So I can do this with na omit. So this na.omit function, or there's another one. You'll see at the bottom. I think I use it later in the code here, called drop_na. Right, and if you're using the piping features and you've imported tidyverse, you can use the drop_na. All right. So plot beaches. We remove the missing values. One of the things we may want to do is make sure site is a factor. So this is important because if ggplot recognizes something you're supplying to it as a numeric, it will plot it differently than if it's plotted as a factor. So if I were to say put this in as a numeric, it's going to plot it as a continuous value rather than individual categories. So what I'm going to do here is just use the mutate function to make sure that site is classified as a factor. Again, I just say the ggplot function after I've imported the data here, and then I'm going to supply 3 aesthetics. Again, we're going to have on the x-axis here, on the y-axis beach bug, and then we're going to separate by color. We're going to put geom jitter, and then I can use this coordinates flip to then put the x-axis on the y-axis and the y-axis on the x-axis. All right, now I'll answer that question in just 1 second, Jenny. I'm just going to run this code real quick. It's going to save P3, and then I have a lovely little plot right here, right? And so it's got all these different colors for the sites, all of them plotted out. And as we can see here, Tamarama Beach kind of seems to predominate here at the bottom, with a lot of the light blue and greens up at the top, but it's still not exactly extremely helpful. Yeah, so the difference being is, so there's a couple different things. So good point, Jenny. You can put NARM equal to false. I just like to pipe in the data ahead of time by omitting here. The key portion here, though, is when I'm supplying it NA omit here, it's omitting any row that has a missing value. So let's say we're only interested in plotting year and beach bugs, but we have a missing value for site. So like say that someone recorded the year or the date and the number of beach bugs, but forgot to say the beach, that value would also be dropped. So the NA omit is just essentially going through in a row by row case. And the way you can get around that is we could just say select and then say site, year, beach bugs, right? To make sure it's only the data we need. And now it's only going to omit missing data for these three values. All right. And really, it doesn't matter that much because ggplot will still plot the data. It'll just remove those values for you. It's just a way to avoid this little warning message here. So I like to, that's, so again, it's just a personal preference, but what Jenny, yes, it will only remove cells rather than the rows entirely, depending. So in that case, what that does for you is if you say geom point and you only have the X and Y value for year and beach bugs and the aesthetics, it will only remove that value if it's missing an NA value for those two columns, right? Because it needs both of those aesthetics to plot. And if one of those is missing, then it removes it. Yep, exactly. So you can do that, but I like to do it in a more tidy fashion. So that way I'm not right. So let's say I have multiple aesthetics. So say I'm doing like a geom point with like I'm plotting all the points and the summary statistics. I'd have to write NARM again and again and again. So it's much easier for me just to select the rows or the columns I want and then supply the NA omit or drop NA function. So again, we have a lot of overlapping points here. And in this case, see, even year is now being considered a continuous value, right? Because it's only plotting some of these in the aesthetics. One of the things I can add here is a facet wrap. And facets are essentially, you know, like in plots, you'll see like figure 5, panel A, B, C, D, E. Well, facets are kind of an easy, quick way of doing it. It's going to make subplots within the plot for each value within the facet wrap. So again, this is why I have as factor, because it'll throw an error if I give it a continuous value, typically. Now, there are ways to do it for continuous values by binning them. Say like you have, you know, a continuous value between 1 and 100, you may do everything less than 25, everything between 25 and 50, 50 and 75, 75 or greater, right? And then you'd have 4 facets. But let's give a look at this. So it's the exact same thing we have above, except we're going to drop the coordinates flip and we're going to add a facet wrap by site. Right? So it's very nice, you know, little label for each site at the top. Now, if you want to, there's even a way within Facet Wrap where you can give it, supply it the column name. So it could say site tilde beach name or site name. But the default is just to plot the value there, right? So if these were 0, 1s, and 2s, you know, et cetera, instead of saying Bondi Beach, it would say 0, 1, 2, so on and so forth. So we can even zoom out just like so. And then the nice thing about Facet Wrap is that it keeps the X or the Y axis and X axis consistent. So you'll notice, you know, 2014 lines up to 2014 on all of these, and same thing with, you know, 5,000. In some cases, you don't want to do that. And so you can set scales equal to free, and then it'll adjust the Y axis for each plot depending on whatever aesthetic you're supplying or whatever scaling that it would require for those values. But that's the default, and that keeps everything consistent. And you'll see here in this case, we even set color to council this time. So there's 3 beaches for the Waverly Council, and 1, 2, 3, 4, 5, 6, 7, 8 beaches for the Randwick Council, right? So we were able to do 2 different things. We were able to facet by beach and add colors by council. Pretty nifty so far. One of the things we may want to do is add a filter for outliers. Something that just doesn't make sense isn't, in my case for physiology, if it's, if I get a core temperature of 60 degrees Celsius recorded, I'm going to remove that value because it's not physiologically possible in any of the studies that I'm doing. So in this case, we may want to add a filter and just say, keep only those with a value of less than 1,000, right? And again, we'll do the exact same thing with a jitter and a facet wrap. Yeah, and it changes it a little bit this time. In this case, we're going to do a facet wrap by site and color by site. So you may even want to remove a legend in this case because they're already labeled, right, on each one. So they know Gordons Bay East is going to be green because it has the label right above it. That's a little bit nicer, right? And you're able to see a little bit more spread in the data because we're not having to go up to values of plus than 1,000. Those are already removed from the plot. So we can compress the y-axis a little bit. So we can see a little bit more separation from those points. And that's the way, R kind of works. It's all about kind of layering. We start with the supplying of the general aesthetics, and then we can add things to the plot, right? And you can just keep on adding and adding and adding ad infinitum. But obviously, the layers are added in sequential order. And sometimes if you add a new layer of some type of geometry here, it can overload. I had trouble removing the legend. How would you do that? Okay, so we can remove the legend just like this. Oh, and by the way, I just want to be clear here. When it comes to R and ggplot, there's a lot I can do just off of memory. I still have to Google it. I still have to go to the ggplot cheat sheet sometimes, just because I don't remember. But the easiest way is to call on the theme itself. So I can say theme, add a plus sign at the end. So anytime you need to add a new aesthetic, you always do a plus sign. And I can say legend position equals none, right? And it plots and that's removed. And then sometimes you may even want to do something like this. Right. And so then we can even, we can put it, top, bottom, left, right, or we can just tell it none. And so that way it's gone. And again, we can add the filtering. So it's all about, how the data is supplied to it. So if we tell it here, everything less than 1,000. So we're just doing the exact same thing again. So let me just add this as well. There we go. Yeah, we add this as well. Yep. And so it's the exact same. Well, it's not the exact same, but it's pretty much the same plot, except now that we've filtered for site, what it's done for us is it's only going to plot the 2 remaining sites left, right? And so now we're down to 2 colors, 2 sites. And again, now that we have more space and we've reduced the axes here and all of the, and the different sites, we could see more of the individual data points. And now we're at a stage where we may have something we want. So let's say P6 is the one we want because we have a report we're writing up on the bacteria levels at Bondi and Coogee. So we can use the here function, and that's essentially telling it where to put it. So we say here, we want to put it in the output folder. We want to save it as Coogee bondi.pdf. Now you could save it as multiple different file types. So if I go /gg save, there's a bunch of different options, so we can adjust the pixels, to give it a higher quality. But I like to do PDF because it tends to be less memory intensive than other file types. So if I were to save it as like a .tiff file, I think there's some journals that require a TIFF file. Why that is beyond my imagination. If you save it as like a .tiff and put up the DPI to like 1,000, you may have like a 75 to 100 megabyte file. But PDF files tend to have a very high quality as far as image rendering resolution, and tend not to take up much memory. So we can do GG save here. cookiebondai.pdf and P6. You can overwrite these files by rerunning it. One of the things to remember is that if you're using a Windows machine and you have the PDF already open, so let me actually close all tabs. So I've got some work open there. And we do ggsave output cookie bondi. It says it saved a 8.98 to 7.75 in image. Now you can adjust this by giving it the height and width arguments. So sometimes what I'll do is I'll do it kind of iteratively, like I'll do 8 by 12, 6 by 7, and keep going until I have it the way I want it to look. So if we go back under files, week 3, output, we now have this little file here. And it looks just like that, right? Very high quality rendering. And if we look, it's 42 kilobytes, right? So something I can easily email anybody. And the good thing about PDF files is it's very easy to export them to a different format using something like Adobe. So I've had to export my PDFs to a TIFF or a JPEG file because for whatever reason, journals require them. Beyond me. Anyways, so we've done kind of the individual point, dot and point plots. But for a lot of times we want to show summary statistics, right? So people want to know, yep, that's all fine and dandy where the individual points are, but where's the median mean differences and how, what's the summary of the spread of the data? And in my opinion, you kind of, in a lot of situations, want to do both. So in this case, I'm going to introduce box plot and violence. Now, everybody, should be kind of familiar with box plots. They're, pretty rudimentary, where you're showing the median, interquartile range, and then the whiskers for kind of the outlying values. So we can create something called pbox1. Again, we have the data, we pipe it. In this case, I've switched from the NA omit to drop NA. And that's just because they're pretty much equivalent. Now, I know someone somewhere that's developed tidyverse could tell me why you would want one versus the other, but as far as this situation goes, they're going to act similarly. In this case, we can just apply it to the ggplot. We can give X for site. So on the X-axis, it's going to be site now. So it's going to plot all the beaches on the X-axis. And then on the Y-axis, what I actually want is the beach bugs values +1 and the log value of it, right? And because when I was looking at the raw data, I saw a lot of values clustered at 0 and then a big tail, right? And so to me, it kind of looked like a log normal distribution. Now, here's the thing. Remember last week when we were summarizing the data, there was a lot of zeros in the data set where they just didn't get any bacterial counts at a beach. So we want to add a +1 there, right? And so we add +1, then we do the log transformation. That way we don't get missing values in case a value is 0. All right, and then we pass it on to a box plot, geom box plot. And that simply just creates a box plot for each individual category of X. And then the chord flip, which again is just going to flip the axes for us. So we can run that. And then we just have our kind of typical black and white box plots, each individual beach here with the box plot kind of showing these outliers up here. Now, one of the other things we could do is, and I'll get to, is transform the axis rather than the raw values. So that way, when we look down here, we actually have the raw numbers there. But again, that can be a little bit tricky because we are dealing with a situation where we have a lot of zeros in our data set, and that can cause some skew issues, or that can cause some values to be lost when you perform the transformation. So I like to actually transform the data and plot the transformed data. Remove 598 rows containing non-finite values. I am not sure. Well, so I'm not sure what happened in your code to give that. My guess is if you look at the data set that's being piped into the ggplot function, what you have is a lot of negative infinities. So let me run this. See if we can produce the same error. Yeah, so what's happened here is you don't have the +1. So every time it's performing a log on a 0 or negative value, it creates a non-finite value or a negative infinity in the data set. And ggplot's getting handed that value and going, I don't know what to do with this, so I'm going to throw it out, right? And that ends up being 587 rows of data. Now, let me be clear. The videos that we kind of worked on from the Sydney Our Lady's data are great, but I really don't like the way she plotted a lot of the data. And in particular, plugging the log value without the +1, because if you're removing all the zeros, you're losing 587 values. And those are real values. They really did measure 0 levels of bacteria or non-detectable bacteria levels at those sites. And in my opinion, you would want to summarize that on your plot. Okay. So, and again, that's not a, well, I think it is kind of an issue, but that's a preference more than anything. Not a, you must do it this way. Okay, and then the other one is a violin plot. And now, if anybody's ever seen a histogram, what a violin plot is doing is just doing a density plot. So it's kind of just what you could call like a smoothed histogram to show the distribution of the data. So in this case, again, we may filter for bug year sites equal to true. So that way we're only looking at the bug year sites, which we programmed in, I think, last week. Again, in this case, I'm going to mutate and create year as a factor. And so that way it's not considering, it's not looking at that and saying 1991, that's 1,991. It's saying 1991, that's a category rather than a raw value. On the x-axis, I'm going to put year. On the y-axis, I'm going to put that log transformed beach bugs value. I'm going to give different colors for year, and I'm going to give a different fill for year. So color and fill are assigning colors, each of them. But color is essentially more affecting the border. So if we were to do it for box plot, all of these lines, these black lines you see would be affected by color, and the inside of the box would be affected by fill, right? So think of color as being like, an exterior paint to the house, and then fill being whatever color you paint the inside walls of the house. That's the best description I have. And there's a lot of times where I plot something and I've assigned either fill or color. I look at the plot and go, no, I wanted the opposite, and I have to go back and change it real quick. And again, we supply it geom violin, which is going to create the violin plots, and then the facets wrap. So that way we have a different facet or subplot for each site. Took a little while longer to process because it's doing a lot more computations inside there. Now we have a nice little plot like this, right? So it's exactly what we have before, except it's separated by beach site and different colors for year. You see the different colors along there. And luckily it's, already ordered in the right thing. The one problem with assigning factors is that sometimes it'll switch the order on you. And then you have to go back and reprogram the factor so that way the order is the way you want it to be. So we have this. It's pretty nice. You can it gives you a good idea of the distribution, but it's not giving you any idea where, or the density of the number of points at each point. But, you don't have any summary information here as far as like mean and standard deviation or variance or spread. Or you do get some spread as far as range here, but not much else. All right. So we can move on to a little bit more advanced violin plot. Let's see what this one looks like. Yeah, or less advanced violin plot, where it's just the year. So it just is compressing them by year and not including different sites, which not much interesting happening there, but not too bad. One of the other things we can do is add a histogram plot. So we may, we can get it down to a particular site and year. So say we just want to look at Cloverleaf Beach in 2018. What we can do is plot beach bugs on the x-axis, and then we can create a histogram by just supplying it to plus geom histogram below it. Let me actually even line these up correctly. Control-Shift-A. There we go. And then the bin width equal to 1, meaning each bin is a value of 1. So each different value is going to get a different bin. And one of the things we can do is even transform the axis, as I mentioned earlier. So rather than transform the values, what I've done is just added 1 to beach bugs. So zeros are now equal to 1 and 1,000 is now equal to 1,001, right? And now what I can do is just transform the axis. And you'll see why this is nice, because what I have here is the count values. This is the number of observations on the y-axis. And on the x-axis is the actual value for beach plugs plus 1. You'll notice that the distance between each one of these marks is smaller or different from each other. Some smaller, some larger, right? And that's because it's log transformed, okay? And so what's nice about that is that we could see the actual value. So in this case, ones would be 0, right? But in this case, this would be a value of 1.71, right? So right about there is our highest count of points within that bin there. Okay. So as I mentioned earlier, that's just a basic histogram. I very rarely do those just because usually you want something a little bit more complicated than that, but you can adjust the bin width. See what that looks like. Yeah. To kind of fit your values a little better. So let's even do like a little bit different here. Right. And so that's just adjusting the number of bins or the value at which the bins would change. So we can even go a little bit smaller, get even more bins, right? But overall, I like doing the more smooth geom density or geom violin. All right. So one of the nice things I mentioned earlier about ggplot is that we can layer the aesthetics, right? Or the geometries here. So we can filter through just like we do. We filter the data, transforming years to factor, only including where bug year site is equal to true. And then when we get down to ggplot, I'm going to log transform again, +1, put site on the x-axis. Then what I'm going to do is I'm going to give it a box plot and then geom point. And what's interesting here is I could say, I want the points to be colored by year. But in this case, because I haven't supplied the color up in the ggplot aesthetic, boxplot is not going to be assigned a different color by year. Okay. And then again, coordinates flip. So x on y, y on x. And that's what this looks like. All right. So it's very similar to a plot we had earlier. But in this case, we have the individual data points overlaid on top. Now, this is why order matters, because if I just do this, now the box plots are on top of the point. So the way you order things are going to affect when and where they're plotted. All right. So if we want to have the individual data points on top of the box plot, it needs to come afterwards. And that'll become really important as you're maybe plotting a XY scatter with a trend line through it, right? You would typically, I would say, most of the times want to plot the points and then have the trend line over top. But in some cases, you want the individual data points to be more prominent. So you may plot the line first. Did someone have a question? No? Okay. All right. And then one of the other things we can do is that GGB swarm package that we put in, they have something called geom quasi-random, which is a little bit nicer, in my opinion, of plotting the individual data points compared to geom jitter. So if we import that package, all we have to do is say geom quasi-random. We can again assign the color. In this case, instead of a box plot, we can plot the violin. So the combination plot is almost the same. This is really the only difference, is that we've just switched box plot for violin and point for quasi-random. And we've also removed some of we no longer have the coordinate flips, and we also have moved from year. Instead, the colors are now site and the x-axis is now year. So what we have here is these nice non-overlapping data points, and they fill in exactly where you see the expanding areas of the violin plot. So it almost kind of looks like our violins have chickenpox. Any questions about that? So now we're getting into layering. Now we're moving into more advanced parts of R. And here we're actually going to get into the summary statistics. So in a lot of cases, like for a journal, you may want to show the mean and standard deviations of these groups over time, right? So you may not even be interested in the individual data points, or there may be so many data points where it's confusing. So what we're going to do is combine essentially what we did last week, which is summarizing the data with ggplot. Okay. So we're going to go through this whole process again, except we're going to add in a summary phase. So we can say plot beaches, pipe to drop NA. So we're going to take our plot beaches data set, drop the missing values. We're going to group by year and site. So we want values, we want these summary values plotted by, grouped by year first and then by site. Within that, we're going to create a value called mean bugs, which is the mean of the log value of beach bugs plus 1, right? And in this case, the reason I'm doing that is we know the data is very skewed. So the mean of the raw data is going to be misleading. Okay, so what I would want is the mean of the log values, because that's actually going to tell us what the actual, it's going to be a more representative value of the distribution. And then we put in dot groups equal drop, and that just drops the grouping variable, right? Otherwise, that can kind of be funky with your code later, right? So once you have all your summary information, you just add this to the end. Then you pipe it to the ggplot and say, I want year by mean bugs, right? Because this data set here, let's just take this. What it's passing on to ggplot here is a table that has year, site, and then the mean bug values by year and site. Okay? So we want year on the x-axis, y, mean bugs on the y-axis. We want geom column, so that's going to give us a little bar plot, which again, I disagree with some of the plotting options of the videos, but you can do bar plots. I highly recommend not using bar plots. As I say here, note from Aaron, I hate bar plots for continuous data. Do not use them for publications. It makes no sense. I could go into a tirade for an hour just on that. But again, we'll just add the columns, and then we can add a facet rep by site. Right, and then what we see here is a bar plot where the top of it is indicating the mean value by year. And again, I've created it as a continuous variable this time, but we could make it categorical, and by site. Right, so you may even notice here, just looking at the raw values, that Malabar Beach and Coogee Beach tend to be much higher almost every single year compared to, say, like Gordons Bay or Bondi. All right. And we can make it even a little bit more advanced by showing more summary statistics. So again, we pipe through, in this case, we've dropped the grouping by year and just gone by site. We do the transformation on the log values within this to get the mean. We do the transformation within the standard deviation to get standard deviation of those log transform values. And then we could even get the number of observations just by the n function. And then we can calculate the standard error by taking this n value and this SD value, taking the SD divided by the square root of n. Now, again, I would not plot the standard error. So what you have here, when I pipe it down to ggplot, is on the aesthetics, I say x is equal to site. So on the x-axis, it's going to separate by site. On the y-axis, we're going to plot the mean bug value. And then I'm going to supply two more new aesthetics called ymin and ymax. All right. And I'm going to set those equal to mean bugs minus SD and mean bugs plus SD. All right. And we'll get to why that's important in just a second. And then I'm going to have two geometries and an option here. So geometry 1, I'm going to do the columns just like we have over here. Then I'm going to add error bars. And then I want to flip the coordinates, right? So I'm going to put everything. I'm going to plot the sites on the y-axis and the value of mean bugs on the x-axis this time with the coordinate flip. And so what geom error bar is doing is it's plotting at each individual site here, because that's what we have on the x-axis. It's plotting this value as a top and a bottom, right? So we can just do this. It looks like this, right? So what it's done here is, in this case, the Y max value for Tamarana Beach is about 3.5, and the Y min value is about 0.4, I would say. And that's what it's putting in for the error bars. And so then you can change the aesthetics of the error bars as well to make them, thicker, smaller, different colors. But really what it's doing is all it needs is that Y min and Y max aesthetic. And then you get nice little error bars. In this case, the standard deviation. So If this was a normal distribution, 2/3 of the points sampled from that population would be between these error bars. But we could also do the standard deviation or the standard error. I just don't like to plot that because I think it can be misleading about the spread of the data. So another value or another data set we have for this week is the rain temps. So this is the case, if you want to plot more of like a correlation, are these two values associated types of plots? That's what this data set's for. So we're going to use the here function. We're going to say, look in the data folder for rain_temp_beachbugs.csv, and then read CSV there. So it's going to give us a data set called rain temp, right? Give it a little look real quick. So very similar to our other data set, except it's going to give us, the council, location, date, the site itself, the beach bug values, ID of each, the region, as well as the rain in that area that was measured in the past day, and the temperature of the airport at the time it was measured as well. Okay. So we can create a simple association plot by this. We import rain temp. We can filter out anything less than 500. So we may only want to look at, we may think there's a relationship between rain and beach bugs only when the raw value of beach bugs is greater than 500. So in that case, we're going to filter out all rows with beach bugs value less than 500. So pretty much everything visible here is going to be gone. So on the x-axis, we can show rain. On the y-axis, we can show beach bugs. And then we want to color each of our points with by the temperature of the airport. And that's a continuous value. So now you're going to see what colors look like when the coloring aesthetic is continuous. We want geom point. So that's going to create a scatter plot, and then geom smooth. Now geom smooth is going to create a smooth line through those data points. There's a lot of different options within geom smooth. So the default option is kind of a smoothed line. So it's going to be kind of this like wild looking trend line because it's doing the smoothed average across those, or the locally estimated smoothed average. So let's give a look at what P_rain1 looks like. Looks like this, right? So let's go into what's actually being plotted here. So this is what geom smooth gives us, which is the smoothed average line with a 95% confidence interval. The individual points here, you'll notice, are slightly different colors, right? And that's for the different temperatures. So if the temperature is equal to 30, it's going to be that light blue, right? So we know that one's closer to 30 than it is to 20. And then these dark blue values are closer to 20, right? So it's kind of giving us a color gradient. And again, I wouldn't necessarily, that wouldn't be my publication ready plot. But we could change the theme. So this is another nice thing about ggplot is it's very easy to kind of change the visual aesthetic of what you're actually looking at. So, you see this gray background with grids, kind of yucky, not something you typically would see, I think, in most exercise science publications. All right. So we can create P_rain classic. We go through the exact same process again, except at the end, we're going to add something that says plus theme_classic. Notice a white background, really thick, nice lines here. And that's pretty much it as far as how it changes from the base aesthetic. One of the other things I would note is the little warning message. It says geom smooth using method low s and formula y=x. All right. And the reason is if you don't provide these two arguments in the geom smooth function, it'll always produce that warning message because it's going to choose a default option of how to plot the data, right? So we could avoid that issue. We could avoid that issue by saying method equal low s, formula equal y by x. All right, and it's going to produce the exact same plot for us, but no warning message. Okay. And we can also adjust the color gradient. So there's a lot of scale_color whatever values within ggplot or within R in general, and it depends on what package you have imported. So we can go through the exact same thing, but we can use the scale color gradient function to say I want the low values to be blue and the high values to be red. Right, and then it's exactly what it's done is that they're red when they're close to 30 and they're bluish when they're close to 20, right? And that's the only change that's made to the plot. We can also, select from palette. So there may be a palette that shows a scale like that. And you can do that through the scale color distiller function. There's a lot of different color palettes to choose from. You don't have to set them directly, such as this. And again, some of them are colorblind friendly, and some of them aren't. I don't believe this one is, but it's essentially doing a very similar idea where very light blue is 20, or dark blue would be lower than 20, to light blue to yellow to red, right? And that's the scale it creates. Kind of gives you this kind of what I would call like 60s chic or 70s chic color spectrum. But that's the distiller function. And we can even go a step further by adding kind of more publication ready titles for all of our different, labels here. So in this case, we want to say X is equal to capital R rainfall in millimeters. Y is equal to mean enterococci bacteria levels. And we may even want to put the units of measurement there, which I think are just count, but you could put that in the figure caption. And then in color, we can say temperature at airport degrees Celsius. And what I've done here is there is a way to directly code in the degrees Celsius. What I do is I go over to Word, get the symbol, copy and paste it into ggplot. There are simpler ways of doing that, but for some symbols in the script will directly recognize it. Okay, and then I can also say I want the legend position to be at the top. So combining everything we've done so far, we have our scale up at the top. It's real pretty. Looking up there, we have these nice looking axis labels and a good little color scale on the plot. All right, so that's everything that we've done so far put together. Now what I'm going to show you is how I would actually plot the data, which is not this. So in this case, what I would want to do is, what I'm going to do is take the rain temperatures data. I'm going to drop all missing values. So any row with a missing value, you're gone. Now I'm going to create a bin value. So I can use the cut number function to create 4 different temperature values, right? So it's going to create equally numbered bins at 4 different temperatures for me. And then we have bins of different temperatures. Then what I'm going to want is the log transform value for rain, because again, they have a lot of zeros in that data. It's heavily skewed. So I'm going to log transform that. I'm going to log transform the beach bug values. And then I'm going to add color by temperature airport. So I'm keeping this aesthetic, but I've also going to be adding this bin temperature, right? Because what if the temperature at airports is affecting that relationship? I may want to plot that. So once I have all those aesthetics and data input, I'm going to plot all the individual data points. I'm going to create a smooth line. But in this case, what I'm doing is I'm saying I want the methods to be a linear model, right? So just a simple ordinary least squares regression. I'm going to set the standard error equal to false because I don't want those, that gray error bar that we have here. And I'm going to set the formula to y equals x, right? And this is important because we can add different types of values. So if I wanted it to be the plot of y equal to x squared, like a cubic relationship, I could also plot that. But in this case, I just want the straight linear relationship. I'm going to set the theme to classic. And then what I'm going to use is the scale color Veritas continuous. That's what the underscore C means. And the reason I like to use that is that it is a color blind friendly color palette. And I know that it is. All right. And then the labels, I'm going to, just show that it's a log transformation right there, +1. I'm going to give the exact same label for color. I'm going to add a facet wrap now for the temperature bins. Okay. And keep the theme at the top. And then what I have is these nice little plots, which gives me the facets for the temperature. So these are the temperatures between 13.1 and 19.8, the temperatures between 19.8 and 23, so on and so forth. And then we also have the colors, which go from purple to yellow. And then an individual trend line. And so from this data, what I would kind of assume, just off looking at it, I haven't run the statistics on it, so look at the difference in the model, is that there's really no difference in the linear trend line between the different temperatures, but there may be a main effect, right? So that intercept may be shifted, downward or upward depending on the beginning temperature. But overall, there seems to be some type of relationship between rainfall and bacteria levels. Another way of doing it is just to adjust the values just a little bit and actually create a contour plot. Contour plots are nice because if we have all these values and they're overlapping, it can actually show us the density of values. So what I'm going to do is use the geom density 2D filled. It's going to show the counts. I'm going to also show the counts with just a density 2D, add the geom smooth again, which is just going to be the trend line. And in this case, I'm going to actually use the scale fill brewer to show a little bit of different colors or different color palette here. And what I'll also mention here is that I've removed any zero values from the rain numbers, right? Because we may not be interested. If there's no rain, we don't really care what the relationship is, or we may think it may affect the relationship. So we've removed those values. And so I've made that a note on the caption, or a note on the plot by using the caption feature within the labs function. So labs allows us to assign different labels. And then we know that the fill here, based on what I've said here, is going to be the count. So I'm going to say observations, indicating that's the number of observations. I've also made one little aesthetic change here to expand the distance between the X and Y axis. So that way there's no white space. This is advanced, by the way. So if you don't understand what's going on here, totally fine. But I just kind of want to show you the breadth of what you can do in ggplot. So what we have is something like this. So I have the binning in here, but I think I dropped the binning, so we don't even need to have that. It'll produce the exact same plot again. Yeah. So I didn't use the binning for this plot. And then what it's showing us here is the number of values within each one of these little rings, if you will, with the darkest indicating that there's 140 to 160 observations within that area, and then going out, right? So we know that there's really no values sitting out in this white space, right? And we know that in these outer rings, where it's the lightest color, there's between 0 and 20 values, right? So very little in these outer ring areas, right? We have this little outlier up here. Okay, and then we have that trend line showing us, as the rainfall goes up with zeros removed, so does the number of, or the bacteria levels, right? But it may not even be that high comparatively. Okay, and this is actually probably what I would use as a nearly publication ready plot if I were wanting to show the relationship between these two values. Okay, and then also what I have here is an alternative to plot 6. So if we go up to P6, it's this guy right here. So originally this is how it was plotted. And I would plot a little bit different using the ggdis package. And the main reason why is I don't like violin plots that much, because I don't like the double kind of wide of the densities. I actually like to show just one half of it. So in this case, what I've done is I've omitted the missing values. I've mutated based on site to make sure site's a factor. I've filtered just to show Coogee and Bondi. I've created year as a factor, so it's not considered a continuous numeric value. It's, each year is a distinct thing, not a number of years, if you will. I've transformed the beach bugs data, so I've added 1 to beach bugs, so that way when we get down here to the log transformation, it doesn't remove zeros. Created a facet wrap by site, and then I've used the stat half-i function, which essentially is going to create a mean value. It's going to create a 50% interval where 50% of the values are located within. And it's also going to plot a half violin plot for me. All right. And so I've also transformed, I've given it specific labels, given it a specific scale. So in this case, I've done scale color varitus, but D, because the different colors are discrete values, not continuous values. I've given it the theme tidy bays, which is included within the ggdis package, or one of its depends, and then added the legend to the top. Well, that would help if I run library with it. There we go. And it gives me this kind of much tidier plot, which shows me the mean values, the distribution of the values, which we even see once we transformed it, not exactly normally distributed, but in looking into the data, it's log normal is probably the best description of the data. And then it's also giving us this nice little you know, spread value or spread brackets here with these error bars showing us where 50% of the values are plotted within. Okay. The nice thing about gggist is there's also you can also do something else, which is plot the summary values. So you could say that it's a rather than stat half I, you could say stat dist half I, and then provide the mean and standard deviations, and it actually would just plot a normal curve for you. Okay, but you know, if you have the raw data, I just use the base stat half I. Okay, and that is like the boot camp rough intro to ggplot. There's a lot you can do with this. Pretty much, if you can think it, you can plot it. It just may take a little while to do. I've spent whole days just messing around in ggplot trying to get the exact plot that I want. And again, if you just Google it, there are a lot of different examples out there. In fact, I have code out there, some older code, but I have code out there for a paper I wrote a couple years ago, and that was in the paper Basic Statistics for Physiologists that was published about 2 years ago. And that even has some code for how to plot repeated measures data. So that way you can have summary statistics that are connected by a line. All right. Any questions about ggplot and data visualization before we go today? Anybody? Come on, I know somebody's got a question here about ggplot. So it's a lot to go over. All right. Well, please feel free to send a message to the group or to me personally. Oh, wait a second. Okay, I lost you a little bit in the second half. Okay, that's fair. And that was what I expected. I just wanted to be able to show you all, like, again, like how much you can do. You know, I like programs like SigmaPlot and GraphPad, but they're very limited because it's a graphical user interface. It's not a fact that they're bad at coding it, but they're limited in what you can do. You have to enter the data in a very specific way. And ggplot, like I said, if you can think it, you can plot it. You can show, like, let's say you have a very specific trend line that you want to show from a cubic spleens model. You can show that line over top of your data in ggplot. Now, I guarantee you that'll probably take you an hour to do, but you can show it and do it and have save the script so you can repeatedly do it. So again, the power is in your hands to pretty much plot anything in any way you want with any color palette you want. And yeah, it's just extremely useful. There's even packages out there that allow you to display the statistics on your plot. So you can actually automatically, for simple like t-tests and ANOVAs, you can actually even add like the significance asterisks on the plot for you. I haven't shown you how to do that here today because I don't like showing significance values on plots because I think the plots should just kind of stand on their own and just show you the data. But that's a different discussion for another day. Okay, so I got like 1 minute here, and then I've got to go run, take my car in for some maintenance. But next week, we will be going over R Markdown. So the instructions for that should be up here in the next hour. I'm going to quickly upload them. There's 3 videos. This week should be very easy because you're just going to essentially be creating a Markdown document. So if you go into R like this, document, we can just select HTML as the default, knit it, save it as RMD test, and you can create these lovely little summary documents in both HTML and even a Word or even takes a little wider than PDF, a PDF document. And I use this for consulting all the time because it's easier for me to share what I've actually done with my collaborators. Okay, so that's what we'll get into next week. I'll upload that. And then the last week, I have set up to how to do basic statistics in R. So correlations, t-tests, ANOVAs. So we'll get into that in the very last week. But I hope you all are enjoying it. Please send out questions as you have them, and we'll see you next week.